In my last video, I compared CockroachDB against AWS Aurora from the standpoint of latency in a globally distributed database. Today, as some of you may have guessed, I'm going to be pitting Cockroach against Spanner. Apparently this isn't a spanner to everyone, so that's opened up a bunch of existential questions, which I'll deal with another time. To recap on the last episode, CockroachDB was seeing around 5 milliseconds read and 7 milliseconds write latency when talking to Virginia from the Virginia-based application. And the EU user was seeing around 15 milliseconds read and 20 milliseconds write latency, where the application was based in London and the database was based in Ireland. Contrasting this to AWS Aurora, when the user was close to the primary instance of the database, we were seeing reads of around 3 milliseconds, where the application was based in London and the database was based in London, and write latencies of around 10 milliseconds, again, where the application was co-located to the database. The situation in Aurora changed quite dramatically when I wasn't close to the primary region, however. I was reading from a secondary read replica instance which was based in the States. Talking to the secondary Virginia-based database via async replication from the primary was taking around 400 milliseconds on average, and write latency, Virginia to London, was taking around 110 milliseconds. Now I'll deploy a Spanner database and do exactly the same thing for Spanner. First, I'm going to spin the infrastructure up with Terraform, and I'll show you what that looks like. I create a global Spanner database. I'm using the North America, Europe, and Asia 1 configuration, which places read-write replicas in Oklahoma and Iowa. So I won't be able to write to a European instance of the database. Writes will all go to the States. This surprised me. I thought Spanner could handle multiple regions for writes, but it's something to be aware of. Spanner works great if you are where Spanner is, but if your users aren't where Spanner deploys its read and write replicas, as we'll see now, you're going to start looking at higher latencies. That's created. That was a lot faster than AWS Aurora. I then create a Spanner database, which is equivalent to the database I've got running in Aurora and Cockroach. I create a service to talk to it, and I give it the necessary permissions that it will require to talk to the database. If we come into the GCP console now, you'll see that my CRDB latency comparison database across North America, Europe, and Asia has been deployed. Iowa and Oklahoma are the read-write regions. Belgium and Taiwan are read-only replicas, and South Carolina is a witness region. Into that, I have my Postgres comparison database, and that's where I'm going to be making my write requests. With Spanner set up now, I'll copy the private key to my clipboard and I'll overwrite my Google application credentials value there, which is essentially just a base64 encoded private key JSON string. I'll launch the application. I'll set my secrets. I found that it's actually quicker to do a build ahead of time and then reference the image from Fly. Everything else remains the same. I'm logging into the Fly image registry and pushing the image, and then I'll do a deploy. And with that running, we'll start to see read and write latencies now. So to recap, this is a London-based application, but it's having to do a cross-pond write because the only regions that allow for reads and writes are in the States, Iowa and Oklahoma. So we're seeing around 130 milliseconds for read latency and around 230 milliseconds for write latency. I'll tear down the infrastructure. I'll spin up the same thing again now, but this time my application will be based in the States. I'll copy my secrets. I'll build the image. I'll log into the image registry again and push. And finally deploy. Now once that's up and running, we'll start to see latencies again, but this time my user is closer to Iowa and Oklahoma. So I'll give it a couple of seconds to settle in. Having had time to settle in, we're seeing around 40 milliseconds of read latency and around 130 milliseconds of write latency. I'll take down the application one more time. And I'll tear down the Spanner database. I'm impressed at how quick this is. In summary, I was surprised by Spanner's choice of region placement. I was expecting users in Europe to be able to write to an instance in Europe, users in America to be able to write to instances in America and read from them. What I actually saw was if you want to have a globally distributed database, you're dealing with North America, Europe, and Asia, with write regions only in one of those. So for example, from a GDPR perspective, data would actually leave Europe. Data would be stored in Iowa and Oklahoma. That's your only way of writing to the Spanner instance, and it would be then replicated for reads back into Europe. CockroachDB, on the other hand, you can deploy as widely, but if you use a topology pattern like regional by row, users in the States can write to the States and read from the States. Data doesn't have to leave the States, and it's the same for Europe and it's the same for Asia, which allows you to operate one global database and satisfy regulatory compliance in whichever region you're running in. With Spanner, there are different regional deployment methods. You could have your read and write instances wherever your users are, but you wouldn't be using one global database. You would need to install different versions of the database to different locations and upgrade them all separately. Join me next time when I'll compare global latencies in CockroachDB against another cloud provider.